So this is now lesson 11 of Python for data analysis. This is the much anticipated Pandas full treatment. So we're going to go to the GitHub page here and go down to, you can click on lessons, lesson 11. And I will add the table of contents. There's a contents listed here. I'll add the hyperlinks in after class. And so we're going to click on raw, copy that link, go to our terminal, open up a new window, go to our lessons folder, type curl -O, paste that link, download it, and do source activate Python 3, and then type Jupyter Notebook and hit enter. Alright, so we're going to now see the home folder of where we just launched Jupyter Notebook, so we should see that lesson 11 that we just downloaded a few seconds ago. And I'll zoom in here. So as we learned about last time, Pandas is this very rich package for dealing with data frames, data structures in Python, and it's incredibly powerful, and it builds on a lot of the stuff we've already talked about. So some things will be kind of familiar, but typically this is the main package you'll use for importing and working with data in Python. So we're going to talk about series, which is like a one-dimensional data type. It's like a list or an array, but in Pandas it's called a series, and it has additional properties. A data frame, which is a two-dimensional data structure, like a table or an array, or a two-dimensional array, or a matrix, but in Pandas it's called a data frame. We have indexes, which are the row titles, and columns, which are the column headers. Data types, info about the data frame, describing the data frame, reading in CSV files, getting the first few or last few lines of a data frame, indexing with different notation, transposing a data frame, converting to a CSV to an Excel, and reading Excel files, and some brief treatment of the date time format and the functions to convert to date time. So in addition to reading and writing CSV files, you can read and write Excel files with Pandas, which is really cool. It just requires one additional package to install. Okay, so first thing we're going to do is import Pandas and Numpy. Pandas is built on top of Numpy, so it uses Numpy, but when you actually want to call a Numpy function, you need to import Numpy. Okay, so the first thing we're going to talk about is series. So I'm gonna. So series are like lists, and in fact, you can create a series from a list. So that's what we're going to do here. The first thing we're going to do is enter this list, and then view it. So we just remember in the notebook we don't have to type print, because the last thing that we type in the cell will be the output will be displayed to the screen. So we can see we have this list here. So what we're going to do is we're going to use the pandas function, series. So we're going to type pd.series, and then in parentheses the name of the list, and then we're going to store that as this thing called series from list. So we now have a series which has all the same data as the list, but now has, when we print it or when we display it, we see the indexes counting from 0, and we see the data type, which is object, which is a Python language for string. So indexing, you can use numerical indexing. So if we want the fourth item, which would be index 3, we type series from list and then square brackets 3, and we get this item here. Similarly, we can take a Numpy array. So here we're going to create an array of random numbers. And so this just generates an array. We called it myArray, and we're going to run this pandas series function on myArray, and it's going to generate a series. So in addition to, if you recall, I think it was last time we talked about, or recently we talked about using like a fancy index where you can pass a list with numbers, and you can pull out different elements of the list. So Pandas supports that. So here we have a list of integers 1 and 3, and that's going to then be inside this square brackets of indexing. So we're going to get series indexes 1 and 3 from here. So we get this one and this one. And it's nice that it shows us the index just for reference. So that's one of the things that that Pandas provides is both positional and label-based indexing, because these also are considered labels. They're not just positions. And we also have the ability to do slices. So if we take this series, and then in brackets we do a 3 and then a colon, that gives us from position 3 to the end. So that would be 3 and 4 in this case. So that's a very, very basic introduction to what a series is. It's just a Pandas version of a list or an array. So we'll now go on to data frames, which are a two-dimensional data structure. This is the main data type that we tend to use in Pandas because often we have a table of data that we want to import and work with.
Is there like a memory performance or something with doing like a list and series or working with Pandas rather than lists?
Are there any memory like trade-offs or anything with different formats? Numpy is typically faster than a list, so a Numpy array is going to be faster than a list for certain operations. I don't think you're going to see much performance hit with a series, using Pandas instead of Numpy. I think it's a pretty lightweight kind of wrapper on top of a Numpy array. It's basically a Numpy array with additional indexing capability and some additional operations. I'm not an expert on the sort of the under the hood, what's happening and what are the trade-offs, but I think for most of the things we're going to do in this class, we're dealing with processed data, like a table that's the output of some, like oftentimes in science, in bioinformatics is I'm more familiar with that. You'll run other software that will generate a table, and that table is the result of many processing steps that were maybe run using C or another language that was optimized to generate that output. And so when you working in Pandas now, you have a table, you want to generate some graphs, and so oftentimes speed is not the most important thing. The most important thing is usability, which is what Python gives you. So with a data frame, we can, in this example, we're going to take a two-dimensional Numpy array of random numbers that are normally distributed. So we're going to use this random module and this rand_n method. So we're going to get a 5 by 5 array. And then from that, we can just pass that to the Pandas function data frame, which will make a data frame from that. And now we see that we have this data now in a table. So one of the things you'll notice is that Jupyter Notebooks makes Pandas data frames have like a nice interface. Like you get these, like your rows get highlighted when you mouse over them, and it kind of renders it in a nice way, so it's really easy to see what's going on, as opposed to this, which is sort of more basic. So this is the one way to create a data frame, is to take an existing two-dimensional structure and use this data frame function. The other way, which we'll see in a minute, is to import a CSV or an Excel file and import that from a file and then straight into a data frame. So here we just took this data frame. We didn't pass any labels for these rows or columns, but Pandas allows us to, and this is something that Numpy doesn't have, is the ability to add labels to the rows and the columns. So one way we can do this is when we import that 2D array, or when we convert that 2D array using the data frame function, we can pass additional arguments, index and columns, and pass those as a list, and those will be now part of our data frame. So when we don't pass those, it just automatically numbers from 0. So that's a good thing to remember. Like, if you don't pass any names for the rows or columns, they'll just start being numbered from 0. But if you do, then you have the ability to have your own labels. And another thing you might notice here is that in this code, we just typed a comma and then hit enter, and that's a valid end of line. So basically this comma is one of several characters that you can end a line with in Python, and it knows to look at the next line, to complete the command. So really all of this is understood as a single line, but we can for clarity, we can type enter. In fact, just to show you, if I were to delete this and hit enter, it automatically indents. Same with this. So that's not specific to Pandas or anything? That's not specific to Pandas. No, that's that would work. We can try it. We can say so another character that you can use is to start a new line is the parentheses. So if I type, for example, parentheses, that will also work. But if I was to do this, I would get an error. So parentheses, commas. We can also do with strings. We can do like I believe this should work. Okay, interesting. So sometimes I think maybe it has to be in parentheses. So that's a bad example. Trying to think what are the conditions for that where that works. I think inside a function, inside a set of parentheses, you can do something like that. So nice thing about notebooks though is it'll tell you if it doesn't give you an error, it works, right? So you can learn that way. But just a little thing. This is sometimes nice to do because now you can see you have your parameters all kind of lined up here. If we look at, if we want to find out more about the data frame function, we can type pd data frame question mark, and we can see that it takes data, index, columns, And one other thing is if we, this should work. Yeah. So why this works is that these are considered positional arguments. So we could say data equals index equals columns equals, or if we put them in the order that they're expected, we can omit those titles. But if we did something like this, it won't work because it gives us a syntax error. Positional argument follows keyword argument. So if a lot of these functions, they take arguments that have both a keyword and a position. So it expects this thing first, this thing second, this thing third. You can not put those in the order, but then you need to pass a keyword. So there's certain conventions like data frame. You always put the data thing that you're converting first. But if you don't want to do that, we could put this thing last, but then we'd have to supply the keyword. It's a little strange, but if you recall when we did those star operators, and we were able to combine different combinations of positional and keyword type arguments or parameters, we were putting the positional ones first. But anyway, that's like more than we need to know. This is how we create a data frame from some array data. Now, if we have multiple series that we want to combine into a data frame, one way we can do that is by combining those as a list. So here we're going to use that data keyword, although it's optional in this case. We can say we have these two series that we made before. That's going to be our data, and we're going to make a data frame from that. Now, in this example, we probably want this transposed because typically you have your columns are all of the same type. That's sort of how we do things in data science. Is we want your columns to be of the same type, and then the rows would be like the different observations. So we can transpose that data frame using the transpose method. So we're going to transpose x and then store it back as x. And now we have our columns kind of as we want them. Another way to create a data frame from a list or from a set of series is to use a dictionary. So here we have a dictionary of two things, and the keys will be the column headers, and then the values will be the data. And in this case, it automatically understands that each of these key value pairs is going to be a column. So that's kind of handy. Another way we have is using this concatenate function, which we'll talk about more in a future lesson. There's a lot you can do with this. There's a lot you can do in Pandas to concatenate, merge, reshape data frames in very sophisticated ways. So this is just a basic example where we're going to use this Pandas function concat, and we're going to concat two lists. And then this axis equals 1 means we want these to be concatenated as columns. So that gives us the same